B.Sc Part 2 and respected listeners, a very good morning and welcome all of you to today's lecture. Dear students of B.Sc Part 2, I will deliver today a very special and amazing lecture. I have mentioned on the blackboard title as that is the Le principle, which is selected from B.Sc Part 2, Paper 3 Physical Chemistry, selected from Unit 3, title as that is of Chemical Equilibrium. Dear students, I bring to draw your kind immediate notice. On our previous lecture, we were delivering about that is of Le Chatelier principle. Once again, I repeat before proceeding today's lecture, Le Chatelier principle of Unit 3. Once again, I bring to draw your kind immediate notice on our previous lecture, in which according to that is of Le Chatelier, which is the famous scientist, according to Le Chatelier's for reversible chemical reactions on applying by means of temperature, pressure, volume, catalyst, inert gas, equilibrium shifted their directions to remove, in which the apply change is counterbalanced. In such rule or law is known as that is of Le Chatelier principle. Once again, I repeat, when we change by means of catalyst, temperature, pressure, volume, concentration, addition of inert gases on any chemical reversible reaction, in such a position, equilibrium or equilibrium shifted in that direction for the removal to shift the acting change or doing change is now that is of counterbalanced. Such a rule is known as that is of Le Chatelier principle. In our previous lecture, we have also studied about that is of two important factors here. In two important factors here in reversible reaction, first one I have delivered in our that is the previous lecture by means of that is of here that is of concentration. On increasing the concentration, the equilibrium shifted in such a position to remove, that is a forward direction, to produce in such a condition in excess quantity of the product. Again, the product is produced in excess condition, now further decomposed into that is a backward directions here. Second one, that is of I mean to say here, effect of that is of pressure on applying, on increasing the value of pressure in reversible chemical reaction, equilibrium shifted to their directions to have to possess that is of low number of that is of moles here. In our previous lecture, we have also expressed about the various cases by means of del n is equals to 0, del n is equals to positive, and that is of del n is equals to negative here. Dear students, for del n is equals to 0, I have also expressed the basic conceptual. For those reactions in which number of moles for reactant product are present in the same state, in such a position, the equilibrium and its state will be the effect that is remains the constant. No change will be taken into account here. For del n is equals to 0. Now let us today, after the briefing of our previous lecture, now I will deliver today the effect of temperature. First of all, now may I request you all the students, dear students, you know we are having two types of the chemical reactions in the environment of that is of inorganic and that is of organic fields also. You know exothermic reactions, first one, second one endothermic reaction. Exothermic reactions are those that to evolve or to emit the heat. In reciprocal endothermic reactions are those reactions to absorb that is of heat. Such reactions are known as that is of endothermic reactions. I asked you one important question to all the students of B.Sc Part 2. I mentioned on the blackboard here that is of 1 mole of HCl reacts 1 mole of NaOH, or in other words 1 NaHCl reacts 1 normal of that is of NaOH to produce NaCl that is of H2O plus 13.7. Second one I have mentioned here, next one important thermodynamic quantity that is of del H is equals to its negative sign minus 13.7 kilocalorie. Now I asked you a question, upper this one reaction is correct, second is one correct, this one is incorrect, or both are that is of incorrect, or one is correct or another one that is of incorrect. Student totally gets confused, because on the behalf of positive sign, students define exothermic reactions. On the behalf of positive sign, student defined exothermic is heat evolved. But what is the role of our next enthalpy del H? Why it becomes negative value here? In order to explain the distinction between heat and that is of plus 13.7. This value indicates for heat. And next one positive value of heat, negative value that is of enthalpy, same value. Now let us try to understand first again. Let us try to distinguish between that is of enthalpy and that is of heat. In order to explain about the distinction of enthalpy and that is of enthalpy and that is of heat, I am taking here a very special example of beaker, in which I am taking here, I fill here HCl and that is of NaOH. Obviously, there is no doubt exothermic reaction and NaCl and that is of H2 are formed here. Now, first of all, two types of the terminology in thermodynamics one can explain here. First one, that is of system and that is of surrounding. System and surrounding. System is the device which is selected theoretically and practically consideration when temperature, pressure, volume should be taken into account as that is of constant here. In such a position, such device, such instrument, such apparatus is known as that is a system here. I am considering here, I am taking here that is of a beaker. Let us compare to that is of chalk box as container. I mean to say beaker and chalk box container, it is known as, one can classify it as that is of system. I mean to say the chalk box container I am using here, I fill here HCl and NaOH, then this device, this instrument one can say, one can know it as that is of system. I mean to say system is the device which is selected, which is chosen for theoretical and practical consideration or for the taking that is the reaction mixture for reactant and product here. So such device is known as that is our system here. Dear students, once again try to understand here, and that is the rest part is known as that is of surrounding here. Here I take here HCl and that is of NaOH here. Dear student, since this reaction that is of exothermic reaction to eval of the heat, I mean to say plus Q heat will add into that is of surrounding, will go to the surrounding and add the heat total amount of surrounding here. Once again, the rest part is known as that is of surrounding here, exothermic reaction plus Q heat now add into that is of surrounding here, and you know plus Q heat now add the same amount of heat. It will be distinguished in terms of enthalpy. I mean to say the same enthalpy amount is now decreased. That is of, it is symbolized by that is a negative sign. Increasing in respect of surrounding, increasing in respect of surrounding, that is a plus Q, and decreasing in respect of system and symbolized by that is of enthalpy. Hence, one can say enthalpy del H and that is of heat both are equal and that is of in opposite sign. I mean to say that is of, once again try to understand my concept, dear students. Enthalpy here is defined in terms of that is of, here enthalpy is defined in terms of that is of systems, while heat is defined in terms of surrounding the rest part. Now let us, hence in the question number 1 I mentioned here HCl plus NaOH, NaCl, both options are, both the equation are correct here. I advise to you, I appeal to you all the students, you have to select that is of, suppose not any kinds of thermodynamic quantity is given here. Now check the sign, suppose positive sign means that is of exothermic reactions, and suppose a special quantity is given here, that is of del H is equal to that is of minus that is of 13.7. the same option, same equation are the same. Exothermic, next one, 1 mole of N2 reacts thrice mole of N2 twice NH3 plus 93.74 kilojoule. No extra specific code thermodynamic quantity is mentioned here. So students, the judgment you have to think here, the reaction that is also exothermic reaction, its negative value to give the value of enthalpy minus 93.74. Now in coming lectures tomorrow we will deliver the influence of temperature using Le Chatelier principle by means of exothermic reaction and endothermic reaction. Thank you very much. Thanks a lot.